All right. Hey, everyone. So today we are going to talk about binary molecular or covalent compounds. All right. Um, we are going to do both the naming and the formula creation, making the formulas from the names and the names from the formulas on these. So recall that we've been doing ionic. Ionic are a metal and a nonmetal made up of ions, a cation and an anion. Binary molecular or covalent compounds are where they share electrons. These do not use ions at all. So because of that, these will be made of two or more nonmetals bonded together. We actually this is why I called it binary molecular. It will be two nonmetals bonded together. Right? It will not be for what we're doing. It will not be more. It'll just be two elements. Okay. Uh, and because they're not ionic, they're covalent. The charges do not matter for these. So these you don't use the charges at all. You don't do anything like that. All right. So how do they work? Well, the prefixes represent the number of atoms of each element. Okay, the number of atoms of each element. So I've listed the prefixes here, 1 through 10. Okay. Then rule number 3, if the first element does not have a prefix, there is only one of that element. So the only time in binary molecular compound naming that you don't have a prefix on something is if the first element, there's only one of them. Then there's no prefix. So for example, carbon dioxide, the carbon has no prefix, so that means there's just one of them. The second element always has a prefix, even if there's only one of them. Okay. And then the fourth thing here, binary molecular formulas show all the types and number of atoms in the compound. Therefore, you do not reduce them. Okay, there is no reducing for binary molecular. All right. So as in with most of the other ones, it's easier once we do some actual examples. So I'm going to walk through some examples here with you. So first one, dinitrogen pentoxide. Okay, all we're doing, there's no switching, no charges, nothing like that. All we're doing is looking at the prefix. Okay, so dinitrogen. Di is 2, and here we're told we have nitrogen. So we look up the element, the symbol, it's N. This tells the number of atoms. So the di means we have 2 nitrogen. It says number of atoms, not charges. So it's subscript. If you put it up above, I will mark it wrong because it's not where it goes. Pent oxide. Okay, they'll change the ending. The ending for these will all be IDEs because they're all monatomic. So, or because it's all an element off the periodic table. So oxygen became oxide. So pent oxide, penta is 5. So N2O5. I could have made it a little closer, but that's the formula. Okay, these are actually pretty easy once you get the hang of them. Heptasilicon. So we look up silicone. Silicone is Si. Okay. Hepta 7. So it's Si7. Fluoride comes from fluorine, which is F. Tri is 3, so F3, SiF3. Okay. Carbon tetrachloride. There's nothing on the carbon. So if there's nothing on the first one, that means there's just one of them. Tetra chloride. Chloride is chlorine. Tetra is 4. So CCl4. Dinitrogen is N2. Monoxide is mono, and this is oxygen. So notice on the second one, they do use mono, just one. Okay. Tetraphosphorus. So phosphorus is P. Tetra, again, is 4. Octa. Bromide. Bromide is bromine. Br. 8. Octa. Notice here, you could divide both of these by 4, but we don't. We do not reduce them. Okay. Boron triodide. So nothing in front of that. So that's just B. Now, here's like iodide is from iodine. They don't really double up the I's. I saw one thing where they did. They did on one of your polyatomics here. Actually, oh, maybe I spelled it wrong. It does look like triiodide. But that's a polyatomic, but that's a little different. But so boron, triodide, iodine, I, and then that would be 3. Okay. Arsenic, nothing on the arsenic. We look up arsenic on our periodic table. It should be AS, yep. Nothing in front of it, so it's just 1. Okay, monofluoride. Fluoride is fluorine is just F, and then mono is 1, so it's ASF, which is the end of that part. Okay. Onto the back. We're going to flip it and do the opposite. So again, I've listed the prefixes, so it makes it easy. And then there's really no new information. It's just reversing that process. Okay. Remember, the only time you don't put a prefix on an element is when there is only one of the first element in the formula. So no mono on the first element. All other times for binary molecular, you use a prefix. And then when you're doing the name, change the ending of the second element to IDE. If the second element name begins with a vowel, the A or the O ending to the prefix is often dropped. In other words, you don't say like monooxide, you just say monoxide. Okay, so let's do some practice here. So we're just doing the reverse. We got N2O5. So N is nitrogen. We've got 2. 2 of them is di. So it's just dinitrogen. You don't change anything about the first word, about the first element, other than just putting the prefix on it. So dinitrogen. Okay, 5 is penta, and oxygen becomes oxide. So it's pent. Okay, if the second element names begins with a vowel, the A or the O ending is often dropped. So you don't really say pentaoxide, you just say pent oxide. Now, I will tell you, if you're doing your homework and stuff like that, if you write pentaoxide, I'm not going to mark it wrong. Okay, I'm not going to be that picky. It just, you'll get used to hearing it a certain way as we go through them. Okay. All right. Next one. P4Cl8. 4 tetra. P is phosphorus, so it's tetraphosphorus. Okay. Oh, that's right. Yeah. And then 8 is octa chloride. Chlorine turns to chloride. So tetraphosphorus octachloride. Okay. Let's look at the third one. CS2. So remember, the only time you don't put a prefix is when there's only one of the first element. So we don't say monocarbon here, we just say carbon. Okay. 2 is di, sulfur turns to sulfide. Okay. All right, next one. 5 is penta, that's selenium. 7 is hepta, and that's bromine. So bromine turns to bromide. Remember, you're only changing the ending of the second thing to IDE, not the first thing. SiF6, only one of the first ones, so no prefix. So that's silicon. 6, FF is fluorine. 6 is hexa, so it's going to be hexa, and fluorine turns to fluoride. Careful on fluorine. Again, I probably won't mark it wrong, but the spelling is kind of weird. Fluorine is Fluorine. So a lot of times people accidentally put OU or don't put the U at all. All right. Next one. Only one of the first thing, so it's sulfur. 3 on oxygen is tri. Then oxygen turns to oxide. Sulfur trioxide. Okay, last one. We got carbon, we've got 3 of them, so that's tricarbon. And then we've only got one of the second thing, right? But it's the second thing, so the second thing always has a prefix. So 1 is mono, so this will be mono. Okay, and actually says if the second element name begins with a vowel, so iodine begins with a vowel, the A or the O is usually dropped. So I'm not 100% sure. I would actually take this either way, but according to that rule, it would be mon iodide. Okay, if you put monoiodide, it's totally fine. Either way, I would take it. All right, that is the end to that. If you guys have questions, let me know, and good luck.